Hi there, welcome back to the channel. Welcome to a new video, and this one is again slightly different. Although you see the Philips radio in the background, it's not about the Philips. This one is actually about the new PCBs that I've got for adding Bluetooth to a tube radio. Now, if you follow my channel, you probably know that I do like adding Bluetooth to the tube radios. It makes them a lot more useful. It makes them cool with teenagers and young adults. They think vintage is great. They're right. And it makes those radios just a little bit more family friendly. Everybody can use them, because nowadays with the reduced number of stations that you get, especially on AM and things like that, it just becomes, well, a shelf piece most of the time. And with Bluetooth, it becomes something you can use every day. And I don't particularly use it every day, but my daughter does. I like listening to FM on these radios, and FM is great, but Bluetooth makes it really versatile. Now, the previous version of the Bluetooth boards that I had made worked very well. I installed them in a lot of tube radios. A lot of my radios, all my radios have them, and a lot of the radios that friends have brought in have now got Bluetooth on there. But I needed to add another functionality to it. There was something wrong with it. I'll explain in a second, and I'll tell you what I did to resolve the problem. Now, once again, because the project involved designing and producing PCBs, I called on PCBWay, and I want to thank them for sponsoring the project. The boards arrived. Let's see what we've got. Here are the boards. They are slightly bigger than the previous version because now there's another section on it. The previous PCBs, this is them here, were designed as a power supply board for these modules. Now this module is this one over here, which I got quite a lot of, and I bought these because they fit nicely, they work very well, they're perfect for my needs, but they require either a 5 volt or a 4.2 volt battery supply. 4.2 because it could run on a 18650 battery. So I designed a board to provide the supply, and it needed to be electrically isolated so that there's no buzz, no noise from this thing going into the radio. And the way I did that was to use a DC to DC converter, which is this thing over here, which makes sure that the supply, which I obtained from the heater supply, the 6.3 volts AC, which has the chassis as ground normally, does not link to the ground that this thing produces as the supply for the boards. It then works well because no buzz goes through. You've probably seen this before on my channel, and you'll know that it works for me anyway. But there was one problem, and the problem is the audio level. Now, with the tube radios, you may know that this thing then connects to the gramophone input or the pickup input on the back of the tube radios. And what generally happens is you'll connect this up, you'll sync it to your iPhone or to any Bluetooth device that sends out music, and you start playing it on your radio by selecting gramophone on the radio, and then you find that the volume level is pretty low. And it gets loud enough, you just put the volume up. But if you're on FM and you suddenly put this thing in, the volume drops. And that is because the voltage level, the actual level, the signal level that this thing produces, which is line level, is slightly lower, actually quite a bit lower than what the pickup input expects to see. So I wanted to build an amplification stage between this and the signal going into the radio. And that's what I did over here. So my boards now have an amplification stage here. I have the top section, which is very similar to this one here. Actually, it's like that. And the module goes on the right here, just as it does over here. It's got the pins that this module expects to see over there. And then the bottom section is an amplification stage using an op amp. Now, what I've found is, I know this sounds stupid, but when you're trying to use the heater supply, which is 6.3 volts AC, 0 being the chassis usually, and you are then producing a signal which is based on or coming out of the output of this thing that has 0 as the ground, which then goes back to the chassis, You can run into trouble if you want to get an op-amp to work on there. And I tried various options, and the best one that I could find was to actually use a voltage doubler. In other words, I take my 6.3 volts and I produce +9, -9, which powers the op-amp. And then the op-amp feeds the signal out that it received from the Bluetooth module over here. It receives it from here and it pumps it out with a gain. Now that gain depends on the gain you need depends on the system that you've got. You may need a gain of 2, 3, 4, whatever. It can't be too high because you've got the ±9 volts supply, which is produced from the 6.3 volts AC. You've got those two supplies as the rails of your op-amp. And if you've got a rail-to-rail op-amp, you could probably get 9 volts peak to, well, 18 volts peak to peak, but it's probably too high. So you just have to work out the gain depending on your system needs. And I've got a resistor here which controls the gain of the left channel, and this one here controls the gain of the right channel, and it's labeled RF because there is no value at the moment. And I'll show you what we do when we build it. Before I do that, I'm going to show you the schematic and how I came up with some of this logic or some of the design criteria. And then we'll come back and build this thing and see how it works. What we have here is the full schematic for this board. And if you've seen the previous video on the power supply board for the Bluetooth module, you'll recognize this over here. This is very, very similar. We have the usual, 6.3 volts heater supply coming in, full wave bridge rectifier. This ground is a floating ground. It's got nothing to do with the radio ground or the ground for the 6.3 volts AC. It gets rectified. You get about 9 volts over here. Goes through a LM7805 5-volt fixed voltage regulator, connected or set up in the normal way. 5 volts comes out here. And then we use this guy over here, which is a DC to DC converter. What it does is it takes 5 volts in and it produces 5 volts out. However, the grounds here, or nothing within this device, is referenced to the other side. So it's completely isolated. So this 5 volts that we got coming out here is referenced to this 0 volts over there, and that becomes the 0 volt line, which then is the ground of the resulting supply. This 1N4007 diode is just to drop the 5 volts to 4.3 because the device in question uses 4.2 volts, a set 4.2 volts for a 18650 battery. So that is pretty normal. This then supplies the Bluetooth module. What we have here, down here, is just an op-amp preamplifier stage, left and right. These two are identical. This section here, those capacitors are just on the supply lines of the op-amp to filter the supply a bit more. But if you look at this section, which is the right stage, same as the left, we have a coupling capacitor here. I use the 1 microfarad Panasonics that I have. I like them. They're non-polarized and they're cheap. A 10K in and an RF in the feedback loop, so you can adjust the gain by adjusting the value of that resistor. I think in my case I'll probably need a gain of 3 or so. So if I put a 33K in here, the gain of this is 33 divided by 10, so 3.3, and of course it's inverting, so it's minus 3.3, which means that the signal coming out here will be inverted and 3.3 times the amplitude of the one coming in there. Same applies to the left channel, and then we've got two signals here, left and right. They again go through a 1K resistor for the purposes I'll describe in a second. They go through these two capacitors, again the same Panasonic 1 microfarads that I like so much. They come out here, you've got a left and right signal, 100 Ks ground reference, just to make sure that this thing doesn't do popping noises when you switch on and off. This ground is the ground that is the same as the ground going to the module, the Bluetooth module over here. It's also the ground that comes from your stereo, from your input. In other words, it's the ground of your gramophone in or tape in on the radio. Usually it's exactly the same ground as that guy over there, but because of the noise that you would get if you run through the same ground, this basically isolates it. So this whole section over here, which is supplying the Bluetooth module, which is here, is referenced to the ground, the same ground, but via the audio input over there. And the reason I've got these two 1K resistors is if you short the left and right over here, you get a mono signal. They sum to give you a mono signal. They sum the left signal and the right signal to give you a mono signal. You don't short them because you've got a 1K resistor between the two signals. So you're not shorting the output of that op amp to that one. It just makes it a better way of creating, a proper way of creating a mono signal from stereo. If you want stereo, you leave it going through like that. And why is this supply a little bit funny? Well, let's look at it. You see the 6.3 volts over there? It comes down and it feeds this point. Now that's a 6.3 volt AC signal. So what you're getting over here is basically this 6.3 volts AC signal, okay, at 50 hertz in my case, because I'm in Europe. What this does, it's a very simple system. It's a voltage doubler. The signal comes in here. The positive half of the waveform gets rectified or gets passed through by that diode, and it charges this capacitor to that peak, okay? And the negative part of the waveform goes through that diode. So you've got something like this. And that gets used to charge this capacitor to negative voltage. The ground, or the 0 volts, is on the center of that capacitor. And also I use these two caps just to filter out some noise. This ground should be that ground up there at the top that comes from the heater supply, but it's not. And the reason again is to do with the buzz and noise. With this ground actually comes from the audio input, the same ground that we talked about a second ago. That ground over there, which is the one that connects to, which means that we're basically treating this section as if it were already in the radio, okay? We're just using that 6.3 to give us our dual supply. And it gives us a dual supply of about 9 volts plus, 9 volts minus. These two resistors here are to add extra filtering because we've got 9 volts there, it goes through a 100 ohm resistor and then it goes to the supply there. And the negative 9 volts goes to that 100 ohm resistor and it goes to there. Now what this sees is the supply lines of the op amp, but it also sees another 10 microfarad capacitor and a 10 microfarad capacitor, and again some decoupling small capacitors on the supply lines of the op amp, always a good idea. And so you've got an RC filter before producing the final supply to the op amp. A little bit complex, but it works. And the reason it's like this is because the alternative versions that I tried was still a bit too noisy. And what we end up with here is the signal coming from the Bluetooth module, which is, you know, somewhere sitting over there. That signal, the left, right, and ground, go to left, right, and ground. And these then get amplified by the multiple that you choose over here. 3, 2, whatever you want. And again, where is it? Where is it? Same over here. And that goes through there, gets summed or not, and goes through to your stereo. But that ground is fetched from the audio input, from the phono input or tape input on your radio, and it gets referenced to this point over here as well. This is the plan. This is what I've sort of experimented with. I haven't done it on the boards yet. I've received the boards. I want to see if this thing works the way I planned it to work. Now, if you want to use this board just without the preamp, very simple. You've got the same left, right, and ground coming from your Bluetooth module over there. And all you do is you take this signal here. Instead of fitting this cap, you just short it from there to there. And you've got exactly the same thing as you had before. And you would do the same on the left hand or the right channel. You short it from there to there. And that means your signal is going straight through without having the preamplification. You don't need the supply. That means you can just use that this board only with that module. And this is what the board looks like. This is slightly different from the boards I've produced because I've made a couple of changes. This capacitor here and that capacitor there, on the board, the footprint I had was the 2mm separators between the legs, you know, the pitch. I felt that was too small because I wanted to make the holes bigger. So I changed this to 3.5 millimeter. There is a hole under here, believe me. I changed this to 3.5 millimeter. So I had to shift things a little bit. I made that a little bit bigger as well. It was a little bit too small. So the components ended up being a bit cramped, as you will see when I show you the built version of the board. So what I want to do is any changes I need to make, I will make them, and then I'll upload the corrected version of the Gerber files onto the PCBWay website so you can copy them or use them to make your own boards. But let's see how this works first. So here's the board. Came out beautifully. Everything seems to be correct, and I'm going to build it. Now, I'm not going to bore you with the soldering. It takes quite a lot of components. The component count went up quite dramatically from that first version, but I think it'll be worth it. I really do. So we'll do this the magical way. There we go. That was quick. That was quick. No problems. Everything soldered pretty well. I made a few errors. I realized afterwards. It's not so much errors as I needed to make a few adjustments. Things like the spacing between those caps was a little bit too tight. The spacing between the holes for the audio out is a little bit too tight. So on the corrected or the adjusted version of this board that I will be posting so that it can be shared on PCBWay's website, we'll have those corrections done. And the result is this. We've got ourselves our Bluetooth supply over here with the DC to DC converter, right? That isolates that supply from the supply to this thing. And this thing now gets its 4.2 or 4.3 volts over here. It could actually go straight to the 5 volts, but I don't remember why I decided to use the 4.2, the battery supply. But anyway, that's the way it is. I leave it like that. It just takes another diode over there. I've got the audio coming out of the Bluetooth, the module over here. It goes into the op amp and through the circuitry that I described. Now, I did put in the RF. You see that RF there? The RF is the feedback resistor which determines the gain of this board, of this module, of each stage. There's one here and there's one on the other side. I put them on little sockets. These little socket pins come from, it's like a strip of IC socket, and you break off as many as you want. I put these pins in there. It just means that I can very easily remove this resistor and put in another one. And when I've got the right one, if I do want to, I can just drop a solder on there, and that'll be permanent. So this is my board now. I've got 2.2K on 22K on here with the 10K input resistors on each stage. This gives me a minus 2.2 gain. I'm not sure if it's enough. I might have to change that to 33 to give me a 3.3 times gain, but I want to test it. Now, what I've got coming out here is 3 wires, the ground and left and right. This is the output. Okay, going on here. And at the other end, I've just connected the two together because I do want to use this in this Philips, which uses a mono input. This is the ground. The ground is all important because remember, the ground in this particular case, the ground from the gramophone input is serving as the ground for this entire circuit, for all of that, including the supply, okay? I know it's strange, but believe me, I tried the opposite. I tried to get the supply independent, and it just made a lot of buzz. That's what everybody complains about with Bluetooth modules, is this thing buzzes like crazy. We'll see what how this one behaves. Now, these 2 wires are the 6.3 volts AC. Now, word of warning, there is a difference between 0, 6.3 and 6.30 in this particular case. And the reason is I'm providing 6.3 volts AC referenced to the chassis to 0 volts into here to create my +9, -9 volts supply. And the 0 volts for that 6.3 volts AC I'm fetching from here at the output from the chassis, or from the 0 volts at the phono input, which is also 0 volts, which is also chassis. But the reason for this is to avoid the noise. So if I don't have this thing connected properly, if I don't have the proper 0 on here, if I have 0 volts coming in here, then I'm going to get 0 volts coming out here, so this thing won't work. So I've got to make sure that the 0 volts is chosen carefully to make sure that I'm getting the 6.3 volts AC reference to the chassis coming in here. That's why I've got a red mark on this, this wire's got a red marking that tells me that I need to make sure the 6.3 volts goes on the red wire. Word of warning, be careful when you connect this thing to the radio. The heater supply has the capability of supplying quite a bit of current, okay? It's not, a few milliamps, it's a few amps. So if you do short something, you can get some really serious sparks. And also be careful, again, this is very, very important. The output from here is going straight to your input of the gramophone. There are two capacitors here. These capacitors are to DC couple or decouple the outputs. These are not high voltage capacitors. So if you have a hot chassis radio, be careful because you could end up with high voltage coming back into this way, which wouldn't be a problem if you didn't touch anything, but if you did, yeah, be careful. Be very careful with that. Do not use this on a hot chassis radio, okay? Do not use this on a hot chassis radio. All right, now I'm going to connect this up. I'll show you where I connect it and we'll test it. Now when I connect this inside the radio, it'll be soldered in place, but for now I'm going to clip this to this point here, which I know is the 6.3 volts heater winding output. The 0 I'm getting straight from the chassis itself over there, so there's no mistaking that I've got the right ones. That then is providing my 6.3 volts AC and 0 volts over here for that supply and the 6.3 for that one. I've got these two banana plugs going into the gramophone input, and this is very important. This is ground, okay? This is ground, this is the signal. You cannot get this wrong because the module needs 0 volts ground to provide that 6.3 volt, to provide that dual supply for the op amps. And it is now connected to the two signal lines, left and right, shorted together. Remember, I've got those two 1K resistors in there in series, so I can short these together to get a mono signal. And of course, ground on there. Now we're going to switch on the radio and see what we get. So to activate gramophone, I have to connect these two together. Put a bit of volume on there. Now the Bluetooth light is blinking because it's trying to find a device to pair to, and I don't have one paired yet. I'm going to use my iPad, activate Bluetooth on here, and it's found it. MH-M28. Click it on. I heard a little jingle on the speaker there, so it's receiving. And now we're ready to play some music. Let me find some royalty-free music on here. This is no great musical masterpiece, but it'll do. You can hear it already. We'll see how the level compares to radio reception. I've got that up here. It's just coming through a little test speaker, but if I put medium wave, it's still too low. That is far too low. You see, what I want to do is get exactly the same or about the same level when I change from radio to the Bluetooth input. So I need to increase the gain of that preamplifier. I'm going to change those resistors and we'll see what we get. Okay, let's give it another try. Medium wave. Much better. Yeah, I'm happy with that. The sound here is awful because I haven't got the tone switches active, but all I want is to hear the same level on this crappy speaker. I'm talking about audio level, and that's what I want to get. Now, if I push pause on the iPad, I've got my ear, I've got the volume on max, and I can't hear the buzz. I can't hear any buzz at all. There's a little bit of hum that's in the radio itself. This thing's out of the chassis, out of the cabinet. It's just on the bench here. There's noise everywhere, but there is absolutely no buzz coming out of that speaker. And that was the objective. I've got the gain I want, and I've got no buzz. So this thing is a winner. Okay, let me show you what I've done. The resistors I have on here at the moment of 47K. So I tried 33, which would give me a gain of 3.3, and it was just not enough yet. So I went one step further, 47. I could have tried 39, but 47 were handy. I put in two 47K resistors on here. As you can see, very easy. Just pull the one out, put the other one in. And now I can cut these down, put them down, drop a solder on there, and we're good to go. In fact, I won't put a drop of solder on there because somebody else might decide they want lower volume. Who knows? I'll leave it like that and just shorten them and plug them into those two sockets. And my system is done. So yeah, that's how I have adjusted this board. And other than rearranging a few layout issues here, like spacing between wires and so on, the size of this capacitor was too small on the board, so I've made it bigger. Other than that, the board had absolutely no errors. And if there were some errors, that'd be my fault, not PCBWay's. You know, they do what you give them. And if you give them an error, they'll make a mistake. Not their mistake, it's yours. So my boards are ready. And if you want to, you can go to PCBWay's website and you can share I've shared the project. You can use those Gerbers and produce your own. This thing's going to come in very, very handy. I've got 4 holes on here so I can put it on the chassis wherever it's most convenient. Normally I try to keep this away from the FM section. So I put it on the sort of the power supply side, you know, on the side where I got the 6.3 volts supply from. It just makes it a little bit less susceptible to any noise. But this thing's going into the radio as soon as I've got the Philips, as soon as I've got those IF transformers ready for the Philips to be completed. So once again, I hope this is useful to you. If you want to use the schematics, they're pretty visible on the video. Just pause the video and get the schematics from there. So feel free, have fun, and enjoy it. Make your tube radios more useful. Once again, I want to thank you for your company. I hope you've enjoyed that. If you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon. Thanks for watching. Bye for now, and stay safe.